Okay, guys, let's get together. This homework, I noticed that lots of you have very ugly free body diagram.
Okay.
Ugly. Because the free body diagram, just like I draw a picture of a human, without the
That's
head.
free body.
Is this good? So what I need in here?
Dimensions.
I need that thing. And if your free body diagram missing the head, then it's not. It's ugly. Correct? The head of the free body diagram is the reactions. Because the forces, you can see them in your book. The dimensions are there in your book. Yes, we ask for dimensions, we ask for forces, but the most important thing that you need to come up is this thing, the most important thing, the thing that thinks, that makes everybody see it, the reactions. And most of you, and you solving problems without showing what you are solving for. So I have this beam here, whatever it is like this, supported in here with a pin, and here is a cable. Sum of forces, sum of moments, some x equal, y equal, tension equal. Where are these? So you are solved for something that you need to show that I have a cable here called TAB, for example, or BA, or CD, or whatever. I have a reaction here called DY. I have a reaction here called DX. These are very important. I got half point or a quarter point or something on the homework. But in the test, next Monday, you will get at least 1 full point for not beautiful free body diagram. Is this clear? Pay attention to your free body diagram. This is the way of communication between engineers. We have the worst communication skills in the world, engineers, even with our families, correct? So what we do, we don't have good, because what we do, we get the sketches, the diagrams, draw lines here. Okay, so this should be very neat, very beautiful, very nice, very clear. So your free body diagram, you spin it anywhere, anybody will hold it there, should be able to read it. It's a language. It's a communication language. You cannot just put any lines there. Is this clear?
Yes.
Okay. We missed one class, yes, because of the snow. And thanks God, we didn't lose anything else. Everybody's healthy, correct? No car accidents? Good. We talked about we are going to miss the integration. Yes. Find the centroid by integration. In this case, will put us back to track to finish this chapter. We talked about finding centroids, and we wrote the main idea of it. What is x bar equal? Sum xi ai over sum of ai, correct? Y sum of yi ai over a total. Agree on this? And this is for area. If we change it for length, what we change? Change the A to L. If you change for mass, M. If we change it for volume, V instead of A. So this is not something that we need to waste lots of hours on it. So we will solve today another problem with volume, another problem with mass, just to put you in the picture how we do. In our life, why we do all this for us? Because today, the next hour, we are talking about something called distributed forces. In real life, there is no force called a nail, a pin, like this. The forces you work with. Yes, there are some here. This is a force at the end of the cable. Up there is a force like a nail hitting it down. But in real life, above you is the ceiling. It's uniform distributed. All of it is the same thickness. Correct? It is not a force like this. Here, look at this plywood in here. This is not one force sitting here, like this little arrow. It's distributed all over. That's why we need to find about centroids, is how to find these forces, how to deal with these forces that we call it distributed. Uniformly distributed or not, that's all we need to worry about. So, most of them, you can calculate it in volume. If you are able to find the area times height is what? Volume. Volume times the density is the mass. Mass times the G is the weight. So it is all about the area. That's why we focus on the area. After that, if we don't learn about anything else, and tomorrow you are an engineer and you need to think about, I need to find center of gravity. I can calculate the area. Area times height is the volume. Agree? So makes your life easy. Volume times density is the mass. If I need to go to the weight times the G. Done. So that's why we focus on the area. When we deal with these forces, there is no beam like this. Like this. Very thin beam. You look at the pictures that we give you, a beam like this supported here, looks like this. But in real life, this beam is wide. Look, how wide is this? Correct? It is not one line. The weight on it like this. That's what we talk about, distributed forces, that we need to convert it into arrows, because we cannot deal with distributed forces when we make our calculations. You have a roof, this for this room. How I can put this load from the roof on these columns to bring it on the center of the column, and the concentrated force hitting center of the column. That's all about, is how to convert the distributed forces. So the centroids in general, if you can find the area, you are good. Okay? So any question about finding the centroids of the length or area? If you want any question on the length or the area, before we move on, I will be more than happy to solve it. Length or area? And again, you need to look at these sample questions. Helps you a lot. And sample questions could be in the test. How to divide such a shape? I will divide it into 2, 3, 4, whatever you like. You can draw a line in here and deduct the triangle. Here.
Okay. What page is that on?
This is 228. 229 is the wires, the length only. Wire again. Questions before we go? Anybody wants any question of area or length? Area or length? Yes, sir.
Yeah, let's do a length question.
Say again?
Let's do one on length.
Which one?
I think it's 528 or 29, whichever.
These ones here?
The one like that right there. They're not the same book, but just that.
So we have a wire here, A, B, C, D, is built as shown and is attached to him C. Find the length L for which portion BCD of the wire is horizontal. So what we have in here is it like this?
Yes.
And is hooked right in here. And this one here is L. 60 and 80. A, B, C, D. This wire is just like this one. Correct? A pipe like this, correct? It has a weight, and here is point C. C is a seesaw at the park. Agree? That needs to be in equilibrium in order to get it horizontal. So you have two options. You can deal with it as moment around C equal L, this one L, times